Session Chairman, Sri V.K. Purohit, is a graduate in metallurgical engineering. He has worked in Hindustan Gas Limited. Previously, he was working as a Chief Operating Officer, Foundry Division in Chorus India Limited, Pune. He has exposure to grey iron, malleable and edge iron. Experience of over 60 years in foundry industry. I request Mr. V.K. Purohit to conduct this session.
Hello, good afternoon everybody. In this session we have two renowned speakers in their respective field. First is Mr. Vinayak Ghotge, who is a Vice President Business Development for Forens Polymers, Haridwar. And he is a graduate metallurgical engineer and having the experience of ferrous and non-ferrous foundry, about 35 years. And he has a vast experience of renowned company like Fosico, As Chemical, Gargi, and he has published a lot of papers on, especially on refractory coating and sand additives. And Mr. Jitendra Lakhotia, who is a CEO from Akar Foundry, Pune, and he is a director and partner of Akar Dyes and Mold also. And he is basically commercial and MBA marketing from Pune University. And he has received the Best CEO Award from Akma Lean Cluster during the Greaves Cotton tenure. And he has worked in Jain Foundry also, MTech and Akai Castalloy. So now I would like to request Mr. Vinayak Ghotge to share his views on in-situ coating preparation.
Thank you, Mr. Purohit. Before I start my presentation, thanks to 70th IFC Organizing Committee and also Technical Paper Committee for giving me this opportunity to present this paper. In-situ coating preparation, a latest trend in refractory coatings with cost-saving opportunities for automotive and jobbing foundries. I'll just go through a background because it's required. See, in the mid of 20th century, most of the iron foundries were using refractory coatings in the powder form only. The foundries used to get refractory powders like zirconium, graphite, and they used to use either dextrine or bentonite as a binder, soak the powder in the binder overnight, and then use a mixer or even small mixer so that they can use this coating. And mostly these coatings were being used by either brushing or by swabbing, and seldom by spraying also. Technological change. In the later part of 20th century, foundries started modernizing and the automation came into picture. So the automation was not only in terms of molding and core making, the automation was there in coating process as well. The foundries started adopting modern coating processes, coating practices rather, like dipping, flooding, over the conventional practices such as brushing and swabbing, because of the consistency in the coating parameters and because of high productivity. The coating methods such as brushing, swabbing or spraying, it requires definitely skilled operators and also time consuming as far as productivity is concerned. Whereas the processes like dipping, flooding are highly productive and the operator skill required is relatively low. However, such coatings are specially designed with adequate rheological properties in order to control the wet film thickness, coating penetration, flow properties, etc. And keeping in mind these requirements, ready-for-use coatings were developed. That means coatings in ready-for-use or paste form. And then these coatings become very popular. So the present scenario in refractory coatings is most of the coating suppliers supply coating either in ready-for-use form or in paste form. Then subsequently on the shop floor, these coatings are diluted to the required application consistency for dipping or for flooding. And such coatings are normally supplied in 30 to 40 kg plastic carboys or buckets. What are the pain areas in present system? The buckets and carboys warpage during transportation, leakage, spillage problems during transportation, settling sedimentation issues, perennial problem, large storing space because the buckets need larger storing space for storage. Bacterial attack on longer storage, especially in the high temperature ambient conditions, the bacterial attack is quite fast. And shelf life issues. In the sense, normally most of the water-based coatings have about 6 months shelf life, but in case of ambient conditions, very high temperatures, the bacterial attack can be even faster. Too much of handling of the buckets. Most of the automotive foundries or the bulk coating consumers, if you see, they use coating to the tune of 30 to 50, 60 tons per month. So the number of buckets handled are quite high. And that's really a non-value added job. And of course, the high packaging cost. When I say high packaging cost, the kind of water-based coatings being used by most of the automotive foundries for general purpose and for critical applications, these coating prices are such that about 15% of the selling price of the coating constitutes packing cost. So what is the new trend now? The coating can be supplied in powder form. It will be supplied in about 25 kg bags, very easy to handle. Coating will be manufactured in foundry premises. And day-to-day manufactured fresh coating will be distributed to core shop for use. Coating manufacturer normally, along with the product, they will supply you a coating mixer, because such kind of coatings cannot be made by a normal homogenizer mixer, which is commonly used by foundries for homogenizing the coating after dilution. This kind of powder coating requires a special mixture with a special stirrer designer, blade design. These are kind of mixers we provide. The coating will be supplied, as I told you, in powder form in about 25 kg bags. And we also supply a mixer for coating manufacturing. The coating supplier will also train the workman for manufacturing, testing the coating on the shop floor. This is required for the initial purpose. Once the parameters are set, then it's a stereotype operation. And the fresh coating will be supplied day to day. The support required from foundries for this is allocation of a suitable space for mixer installation so that the product handling is much efficient and better. Laboratory for initial testing purpose till the parameters are standardized, and manpower for coating manufacturing. What are the advantages of using powder coating versus ready for use or paste form? Is the supply of coating in just in time. The fresh lot every time, so there is no aging, no bacterial attack, no shelf life issues. And the most important from storage point of view is less than 50% of the storage space is required, because these are all bags which can be stacked one over the other. And the powdered product has a shelf life of 1 year. And unless it is tampered or it gets mixed up with the water, the product doesn't deteriorate. So there are absolutely no shelf life issues for the product. And the most important reason for using powder coating is substantial reduction in the price due to elimination of packing material. Packing material normally in such kind of coatings, it acts as a means of transport of product from one place to other place. It doesn't really add any value to the product. So if we are able to eliminate, then we are able to pass on that benefit to customer. We'll just look at the financials. Presently, most of the foundries use aluminum silicate ready for use coating with a landed cost around say 31, 32 rupees a kg. The powder coating which we now will supply or will offer you it will be have a budgetary price of around 54 rupees per kg. This price may vary based on the product used by foundry to foundry, but roughly around the same price. 1 kg of powder coating will yield 2 kg of ready for use coating. So the effective price of powder coating will be about 27 rupees per kg. Hence, the saving in RFU coating itself is about 4 rupees per kg. Now in this, you can slightly add certain things like electricity used by foundries, but the electricity used is very, very nominal. The cost of electricity cannot go beyond 5 to 10 paise per kg. It is hardly about 3 to 4 units per day, and so it's very, very nominal. The manpower which is used for making the coating, normally in most of the automotive foundries, they have allocated a man who prepares the coating and distributes to the coating tank. The same man can be used for coating manufacturing, so there is no additional cost involved. So if a foundry is using about 30 metric ton coating per month, then the saving will be around 1,20,000 rupees, and the saving per annum will be over 14 lakhs, which is substantial for the kind of for the cost of coating what we are using. It will be around 15 to 17%. So here I have considered the saving in, considering the electric cost, instead of 14.4 lakhs, it will come to 14.3 lakhs. So the electricity is not very substantial, which can affect the cost of this thing. Benefits will be substantial. Now I'll just go through the field trials which we have taken so that it can give you an idea as to how versatile will be the product. This trial has been taken in one of the foundries where the casting is a small volute core. It is a foundry producing automotive casting, turbocharger castings, and the trial was made with about 200 kg coating. The application viscosity was about 15 seconds, and the application process was dipping. And the wet film thickness we got around 225 to 250 microns. These are the cores coated with powder coating made in situ. And this is the casting photograph where you can see the clean casting. The second trial which we have taken is again a critical casting. It's a water jacketed 2-cylinder block, and we have this here also the coating is used by dipping process. Viscosity is around 14.5 seconds, and these are the cores which are dipped using the product, and this is the casting finish what we have got. The third trial we have taken is one of the foundries who are producing bigger castings like transmission housing weighing around 175 kg. And the coating is used here by flooding process. So first was dipping, this is flooding process. You can see the cores coated by flooding. Here the wet film thickness was around 200 microns, and you can see the casting finish inside. It's absolutely clear, no sand sticking. One more trial of transmission housing only, but here the coating application is by swabbing. You can see the core being swabbed in the first photograph, and in the second photograph the coated cores, and you can see the casting finish inside. It's absolutely clean, no sand sticking. This is a coating. The 4 trials photographs what I have showed you, it was aluminum silicate water-based coating. Now the trial which I am going to show you now, this is a zircon-based coating which is used on a larger castings. This was trial that is one of the big foundries. The casting weight was about 3.5 tons. And the product was used by brushing application. The as-made coating Bome was over 100, which was then diluted to about 75 Bome for brushing. Specific gravity was about 1.95. These are the molds which are brushed with zircon-based coatings, and the casting is, it was not possible to collect the casting photograph, but the casting was very clean, and the casting was already left to the customer, so we could not collect the photograph there. So the benefits to the foundries using powder coating technology is just-in-time supply of coating, fresh lot of coating every time, no bacterial attack, no shelf life issues, very less storage space required, and substantial cost savings, which is most attractive to most of the foundries. So to conclude, from the trials what I have shown above, it is evident that the in-situ coating preparation using powder coating technology not only helps foundrymen to use it on all types of castings of any size, it yields substantial cost savings as well, which will help the foundrymen to increase their profitability. Thank you. This was my presentation.
Yeah. Any question, please?
Hello. Yeah, my name is Brijesh and I'm from Siemens. I have two questions. First question will be for the full mold casting process. Any specific refractory coating is required in comparison with sand castings? And my second question is, as you saw on that surface finish, so by coating method or different kind of coatings will improve the surface finish, and how?
See, I'll answer your first question. See, for full mold process, the coating required is definitely slightly different than what we use for sand casting. Number one, in full mold process, the coating has to be highly insulating. And number two, the coating has to be a good permeable coating. Because in full mold process, you don't remove the EPC pattern material. And when you pour the casting, EPC burns out and produces some kind of little slag which should ooze out from the coating layer. Otherwise, it will give you inclusions in the casting. So definitely that coating calls for a different type. It is not a regular coating used in automotive applications for dipping or flooding. Second thing is these coatings are used with a little bit higher Bome because the coating thicknesses typically used in automotive foundries are anywhere between, say, 200 micron to 500 micron depending upon the criticality of the casting. But in case of full mold process, the coating thickness is anywhere between 1 to 2 mm, or sometimes it is 3 mm if your casting thicknesses are very high. So the coating is totally different and it has to be designed differently. Your second question, can you please repeat again?
The type of coating and different coatings, it will be improve that surface finish of the casting, and how?
See, surface finish of the casting depends upon two factors. One is the AFS of the sand what you use, and another is the refractory coating. Okay, so definitely refractory coating will help you to improve the surface finish, no doubt about it. In any process you use, whether it is a sand casting, LFC process, or even your full mold process, coating will definitely help you to improve surface finish. Normally, if you see the sand casting process, people use sand AFS anywhere between 40-45 to 55-60. So when you use coarser AFS sand, and if you do not use coating, then you will definitely get a rough surface of sand finish. So just to make the surface more smoother, and you should have one layer of refractory material between the mold and the metal, which is probably having a more refractoriness than sand. That will help you to give you a clean and good casting.
And type of coating like brushing or spraying or dipping, is any difference in that surface finish, or
Yes,
which will be the better?
definitely, definitely. See, normally surface finish, if you obtain with flooding and dipping, are much better compared to brushing and swabbing. Because brushing, swabbing or spraying, these are skilled operating processes. So you need skilled operators for this. Whereas in case of dipping and flooding, the coating rheology is set in such a way that the processes are stereotyped and it will give you consistent uniform layer thickness everywhere. Suppose you have a, like if you talk, I don't know whether I've seen a motor body casting where there are the fins which are deep to 2 to 3 inches deep. So there the brushing and spraying won't help. The flooding helps there. And second thing is productivity. Brushing and spraying will give you very low productivity. If you are into mass production, then dipping, flooding, these processes will help you to get very good productivity.
I am talking about that bigger casting weighing maybe more than 5 ton.
For that, brushing is the only way. Even more than 5 ton castings are also flooded. There are people who are using flooding for more than 5 ton, 10 ton casting also. It depends upon, I mean, which processes your foundry is going to adopt.
Okay, thank you.
Any further question, please? Yeah, Vinayak sir, I have one question.
Thank you very much.
I have one question for you. Of course, coating is required and it is beneficial for the surface finish and all. But what are the precautions or the disadvantages of using coating? Or what care we should take?
I don't foresee any disadvantages of using the coating, but precautions, what you said is absolutely correct. See, there are 2, 3 times. One is you should use, especially for critical castings like block and heads, you should use coatings which do not generate much gas. Number one. Number two, you should use coating which has got adequate permeability so that when you do the casting, if there are any gases in the mold generated during pouring, these gases should not only pass through the vents, but they should pass through the coating layer also. Second thing is, whenever you are using this coating, either by dipping or the flooding process, the coating parameters which are set as per SOP, one has to follow those parameters very strictly so that you get consistent results casting after casting.
Thank you. Thank you.
Thank you very much.
Thank you, Mr. Vinayak, for your presentation. I would request our session chairman, Mr. Purohit, to felicitate him for the presentation.
Now I would request Mr. Jitendra Lakhotia to present his paper on aluminum, demand of aluminum casting for EV. Now EV is a very popular and buzzword in foundry industry because of it is going to impact the foundry industry overall. So I think he will give a insight about what are the changes and which sector is going to get benefit and which sector is going to have some changes. Please.
Good afternoon. Thank you, Purohit Sahab, for my introduction. Thank you, IFC committee, for providing opportunity to present the paper. And thank you very much, technical paper presentation committee, for your help and support. EV, electrical vehicles, is a buzzword, and it's like coming with a tsunami in automotive field. The disruptions which will be caused by EV are enormous, and most of us are clueless on this, what will happen. So I will go ahead with my small presentation on this. This is my introduction. Since last 28 years, I am serving aluminum foundry industry. In this presentation, I have covered topics of climate change, global challenges, how there will be transition for EV, and why EV, how governments are promoting it, subsidies, then how the aluminum consumption in electric vehicle will change, and what should be the future strategies for aluminum foundry. So we are a part of, Akar Foundry is a part of Vishwakarma University. We are around 60 million US dollar turnover company, and 35% business come from Akar Foundry. We support our customer from prototyping to serial production. All facilities are in-house from proto to serial production, everything. Our EV journey started in 2015 when we first produced some part for Mahindra Gen Z vehicle, and it was sold in United States, Silicon Valley. So we produced headlamp housing and its assembly structure. Now we are also supporting in two-wheeler with a customer named Torque. They have recently launched motorbike, first motorbike of India. We also got new business from Bajaj Auto for their Yulu project, which is like a moped, TVS moped. It is similar to that. Our serial production for Tata Motor EV, Tigor, which is produced in Sanand plant, Gujarat. So we have started its production since last 6 months, and we are also supplying parts to Mahindra Electric for their KUV electric vehicle. Here you can see some images on this, how the part looks like. All are in aluminum castings in a process, gravity, low pressure, high pressure die casting. Recently there was a world committee, all leaders in Davos. They have declared their net zero carbon emission. We know transport industry contributes one of a very large extent of carbon monoxide and carbon dioxide, which creates health issues, and also it is killing the environment. So EV push from the world leaders is natural. India had committed a long time frame of 2070. Some of countries, they want to be carbon neutral by 2030. It looks like this EV sales scenario up to 2050. So there will be all types of vehicle, but the gradually conventional fuel and its demand for the automotive will reduce. Hybrid vehicles will be there, but electric vehicle, it looks like that it will be in full throttle, and there will be an entry of hydrogen fuel cell also. In this slide, I had tried to capture OEM's plan, how they want to convert their cell and how would be the electric cells in their total vehicles production. We know that Scandinavian countries are now front runner to introduce EVs, and most of the new purchases for car in Norway, Finland, Sweden, they are in EV form only. European leaders had committed that most of them want to bring electric cars by 2030. To make EV happening, there are various subsidies provided globally by each country to their OEMs with the incentives for infrastructures, monetary benefits. This is how India will go. By 2030, 80% of our two-wheeler and three-wheeler, they will be in EV. 70% cars, commercial cars, will be in EV. 40% of buses will be in EV. And 30% cars will be in EV. This is information we took from Niti Aayog, their own records. In India, we are frequently going through the word PLI scheme, PLI scheme. And more than 20 OEMs have been approved under this PLI scheme, in which cost reduction of EV will be feasible. And government is providing import-export duty concessions to boost domestic manufacturing of EV. From 2015, India is working on the subsidies through the FAME 1, FAME 2 policies to provide tax benefits for manufacturers as well as end customer. Even bankers are providing cheap loan, and all are trying to boost EV sales. You may also know that our government, our Prime Minister Modi ji, never uttered the word about IC engine. He always say about EV and various plans on green energy. The challenges of EV revolution in India are huge because of the size and demography of the country, unavailability of charging structures, infrastructures, driving range of a car. Still we are having around 300 kilometers driving range. Recently Tata launched Nexon with 400 kilometers. Electric cars are very costly than conventional cars. Battery replacement is huge cost. And disposal of lithium and zinc batteries is also a question mark. Disposal will be at a risk with a prolonged effect of soil deterioration. My presentation is more on aluminum casting. So here aluminum foundries can feel safer. As estimated, there will be no major impact on aluminum casting suppliers' sales. So as the battery weight is more, everyone wants their EVs to have a lightweight alloy, which will add strength. Then aluminum is recycled. It is sustainable and energy efficient. So most of the steel parts, ferrous castings, can be replaced by aluminum castings. So 45% of aluminum will eventually be 60% of a total vehicle. This is simple diagram wherein you can see which parts will not be required in EV, some parts will remain unchanged, and there will be new parts like battery enclosures, mounting brackets, then motor enclosures, covers, ECUs, all this will be required. As I mentioned earlier, some of these parts we have already started production for Tata, Mahindra, Bajaj Auto. This is one schematic diagram of a car, how EV will work, means how the components will be placed. See, charger, batteries, controller, transmission. So, very few parts. Normally, car require around 300 parts, and it will get reduced if a engine, I would say, from 200 parts in an engine will get replaced by 30 parts. So, it will be a huge challenge for foundries. These are the aluminum components where the aluminum content per vehicle is mentioned. Battery box, the biggest part of aluminum in the new EVs. Body enclosures. This is also an interesting story. Tesla, which come up with a IDRA to produce 6,000 ton giga press. You can see in a diagram that so many parts in Model 3 are now replaced in one casting, which offered 10% weight reduction, and 70 parts were reduced with the new technology. They have developed a new alloy also. This is the last slide of presentation. What aluminum foundries will have to do? Since last 28 years I am in this field, and most of my experience goes in business development. I can sense that risk of idle capacity for big foundries will be big risk. Capacity will remain idle. Means parts like engine covers, transmission cases will reduce. Now around 75% of our India's vehicle sales is two-wheeler, and 80% of two-wheelers will be in EV by 2030. By 2025 it should be around 40 to 50%. So the big suppliers which are carrying the presses of a size 250 ton, 400 ton, 660 tons like this, they will have huge idle capacity with them, and this can be a problem for the upcoming new foundries, small foundries. Foundries will have to go with a new product mix. Akar foundry changed its product mix from 80% automotive, 20% non-automotive to 55-45%. So this will be the reality. Very quickly, non-auto segment business must be taken by the aluminum foundries. Those who are dependent on two-wheeler have a major threat. They need to move swiftly. There will be many aluminum structural parts will be coming, which will require high tonnage press. So the demand for good high pressure die casting machines will be bigger. For a player, one of my friend from Noricon is here, so they will have a good thing for here to sell their big presses of Ital press. Development of new alloys, which will have a better strength. Technology will have to be upgraded to cast thinner part. Now it is around 3 to 4 mm. Customer may demand 2 mm to 2.5 mm general wall thickness. And all this will call for simulation of lightweight parts. So digital awareness and digital adaptation will be also a challenge for the aluminum new foundries. Thank you very much. If you have any question, I would be happy to answer if you have any question.
Yes, there is a question here.
Hello, sir. I have a question. Since Akar Foundry have all the various kinds of processes under one roof, that means PDC, LPDC, GDC, tool room. So, in near future, in next 5 years, let us say, which of the processes will have more and more demand?
I guess the ratio of high pressure would be around 80%, and in balance 20% it would be low pressure die casting around 12%, and 8% will be gravity die casting. Gravity die casting will be more suitable for alloy wheels because most of the Japanese company make alloy wheels in a gravity. However, European companies make in low pressure die casting. But the battery boxes for a customized cars like Bentley, Aston Martin, where the volumes will be less, I think that low pressure die casting will be preferred process, even though it is costly on part price. But the high volume cars, they will prefer big press of 3000 ton and above. I hope you are looking for this ratios.
Thank you, sir.
Thank you.
Any more questions?
I believe this was the last presentation.
Yes, yes.
Thank you.
Thank you, sir. I would request Mr. Purohit, our session chairman, to felicitate Mr. Jitendra for presenting his paper. I would like to thank Mr. Vinayak and Mr. Jitendra for participating in the tech sessions and being a part of the 70th IFC and IFEX 2022. Your presentation was quite insightful for all our foundry men who are present here today. Now I request our OC Secretary, Mr. Suresh Chavan, to come on the stage and felicitate our session chairman, Mr. Purohit, for conducting the session.